Welcome to the deep dive. We are here to take that stack of source material you shared with us, all the articles, the research, the internal notes on cost analysis, and really turn it into knowledge you can use, like, right now.
Exactly. And today we're diving into what is, I think, the single biggest hurdle in a lot of financial planning.
The mixed cost.
The mixed costs, yeah. If you're tackling corporate budgeting, prepping for a big meeting, or, just trying to figure out why your own electricity bill is so unpredictable, this deep dive is for you.
We're really focused on getting you this knowledge quickly, but also thoroughly.
Right.
So our mission today, really, is to take these costs that are kind of tangled up.
The ones that aren't purely fixed and, they're not purely variable either. They're stuck in the middle.
Exactly. And we're going to separate them, break them down into their basic predictable parts. And there's a huge why here.
Oh, absolutely. Because if you can't separate those components, you are completely blocked from doing any accurate cost volume profit analysis. CVP it stops.
That is the core problem we are solving. I mean, think about it. If you can't predict exactly how much your costs are going to go up when production goes up.
You're flying blind, totally blind when you're trying to set prices or forecast your profits for next quarter. You have to know the formula.
So let's just lay down the foundation for everything we're doing today. A mixed cost equals a fixed component plus a variable component. That's the equation.
That's it. Our job is to find the numbers for each of those pieces. And this isn't some, abstract theory. It is the reality of almost every single business expense.
Your sources had some great, really relatable examples. The first one that always hits home for me is the utility bill.
The factory electricity cost, yes.
You've got that mandatory connection fee, that base charge. That's fixed. You pay it whether the lights are on or not.
But then, right on top of that fixed cost, you have the actual usage charge, the kilowatt hours you burn running the machines.
And that part is purely variable. It moves directly with your activity.
Yeah.
So that combination, that's a perfect mixed cost.
Perfect example. Or think about salesperson compensation, a really common one.
Okay.
You have a reliable base salary for your top sales rep. That's their fixed part. It gives them stability.
But the real money, if they're good, comes from the commission.
Exactly. The commission is a variable percentage tied directly to how much they sell. It's a classic mixed cost designed to, motivate performance.
Even simpler, a cell phone bill.
Yeah.
I mean, remember paying like $50 a month minimum?
Oh, yeah.
But if you went over your data, it was another $15 per gigabyte.
The $50 was fixed. The overage was variable. Same thing.
And one final one from the sources, the mall rent.
Right. For retail especially, you have a set minimum rent each month. That's fixed. But then there's often a clause for a percentage of your sales over a certain amount. That's the variable piece.
So they're everywhere, which means being able to separate them is just, it's foundational.
It's everything.
Okay, so let's get into that. This need for separation. We know CVP analysis has to have costs cleanly sorted, fixed or variable, nothing in between.
Right. You need that predictive equation.
So the question becomes, how do we do it? I mean, how much effort does it take to get that answer?
And that brings us right to the main trade-off for any manager, and it's all over your source material. It's the relationship between effort and accuracy.
A spectrum.
A spectrum. The three methods we're going to talk about all live on that spectrum. The more time you put in, the more accurate your answer is going to be.
So let's start at the very top. Maximum effort, but maximum confidence. This would be method 1, invoice-by-invoice analysis.
Yeah, you called it the financial scalpel. I like that.
It seems fitting.
It is, because what's so interesting here is that this method completely ignores historical data. It doesn't look at trends. It goes right back to the contracts.
So you're saying someone has to manually review every single contract, every bill associated with a cost?
Every single one. If we're talking about that salesperson's pay, you literally pull their employee file and you look at the contract, it tells you the exact fixed salary and the exact commission rate.
Okay, so the advantage there is it's undeniable.
Yeah.
It's the actual number.
It's grounded in reality. There's no estimation, without a doubt, what's fixed and what's variable, because the document says so.
But the drawback has to be huge.
Oh, it's massive. Imagine doing that for a giant factory with hundreds of utility accounts and thousands of employees. It is incredibly resource intensive. It's slow.
A total bottleneck.
Right. So unless the decision is absolutely critical, like moving an entire production line overseas, that level of effort usually isn't worth it. It's our baseline. High effort, maximum accuracy.
Okay, so because that's rarely practical, managers need a faster, a reasonable estimate.
Yeah.
That brings us to the middle of the spectrum.
And this is where we start using historical data. This is method 2, The scattergraph.
The visual approach.
Exactly. And the scattergraph is, well, it's brilliant because it uses all the data points you have. It gives you this intuitive visual feel for how the cost behaves.
The rules for plotting are super important.
Yeah.
Cost is always on the vertical y-axis.
Always. It's the dependent variable.
And activity, so machine hours, labor hours, whatever,
Right.
the always on the horizontal x-axis.
The independent variable. You plot every data point you have, say 12 months of electricity costs. And then comes the estimation part.
You literally just draw a line.
You literally draw a straight line through that cluster of points that, to your eye, looks like it best represents the average relationship. It's called a best fit line.
And that visual line?
Yeah.
That gives us the two components we're looking for.
Instantly, you just look where your line crosses the y-axis. That intercept point, that's your fixed cost.
Because that's the cost when activity on the x-axis is 0.
Precisely. It's your baseline cost.
Okay, I see. And the variable rate.
That's just the steepness of the line. The slope. A shallow line means a low variable cost per unit. A really steep line means a high one. You calculate it with rise over run.
This sounds pretty good. You're using all the data. But I feel like the human element here, the to-your eye part, is a risk.
It is. That's the big drawback. I mean, it's simple, it's visual, and it uses all the data points, which is great, but it's subjective.
So you and I could look at the same data and draw slightly different lines.
And we'd get slightly different answers for fixed and variable costs. And if the stakes are high, you don't really want your profit forecast resting on an analyst's visual guess.
So if the invoice analysis is too slow and the scattergraph is too subjective, managers need something that's fast and objective, even if it's just a rough number.
And that takes us to the other end of the spectrum. Low effort. The blunt hammer, as you put it. Method 3, the high-low method.
A computational shortcut.
Right. It removes all the subjectivity because it's just a calculation. But, and this is crucial, it only uses 2 data points.
The highest and the lowest points.
The highest and lowest points of activity. And this is the first step, and it's where people often get tripped up.
Wait, why activity?
Yeah.
If I'm looking for the extreme cost, wouldn't I start there?
That's a great question, but you have to anchor to activity because activity is what drives the cost. We need to measure the cost change across the full range of operations.
Okay, so let's use the automobile manufacturer data from the source material. They tracked electricity cost against direct labor hours.
Perfect. So, step 1, find the high and low activity levels. In that data, the high point was 18,000 direct labor hours.
And the cost for that month was $120,000.
And the low activity point was 6,000 direct labor hours with a cost of $60,000.
Got it. 18,000 hours and $120K. 6,000 hours and $60K. Now what?
Now we calculate the variable cost per hour. We take the change in cost and divide it by the change in activity.
So the difference in cost is $120,000 minus $60,000. That's $60,000.
Yep. And the difference in activity is 18,000 hours minus 6,000 hours.
Which is 12,000 hours.
Right. So you take that $60,000 cost difference, divide it by the 12,000 hour activity difference.
And you get exactly $5.
Exactly $5 per hour. It's objective. It's undeniable. And it was really fast.
Okay, so that's our variable rate. Now, how do we get the fixed cost out of this?
It's simple. You just take the total cost at either the high point or the low point, and you subtract out the variable part we just found. Let's use the high point.
The total cost was $120,000.
And the variable portion is our new rate, $5 per hour, multiplied by the activity at that high point, which was 18,000 hours.
So 5 times 18,000 is $90,000.
Precisely. So you take the total cost of 120, subtract the variable cost of 90, and what's left has to be the fixed cost.
$30,000.
$30,000.
That was incredibly fast. So the final equation is total cost equals $30,000 plus $5 times direct labor hours. Low effort, 0 subjectivity.
And this is a really serious but. Its biggest advantage is also its fatal flaw.
It ignores all the other data.
It ignores every single data point in between. If those high and low months were flukes, maybe a plant shutdown or a weird power surge, your entire calculation is built on unrepresentative outliers. It's a rough estimate at best.
Okay, so this is where it gets tricky for our manager.
Yeah.
You have 2 estimation methods, scattergraph and high-low, and they can give you really different answers.
Very different.
In our example, the high-low gave us $30,000 fixed plus $5 per hour variable.
Right. But your source material noted that a careful scattergraph on that exact same data might give an estimate closer to $40,000, fixed plus $4.29 per hour variable.
That's a huge difference in cost structure.
Yeah.
So as a manager, why should I care? I mean, my fixed cost is 30 grand or 40 grand.
Yeah.
They kind of get to a similar total cost at high volumes anyway, right?
You should care tremendously. That $10,000 difference in fixed cost completely changes your risk profile.
How so?
Well, if you go with the $30,000 fixed estimate from the high-low method, you're believing your variable costs are higher at $5 an hour. That means your margins are actually tighter on every unit you produce.
Okay. And if I go with the $40,000 fixed estimate from the Scattergraph?
Then you believe your variable costs are lower at $429. That means you have a much higher hurdle to clear just to break even. But once you're past that break-even point,
Every extra unit is way more profitable.
exactly, it's a different operating leverage. A risk-averse manager might prefer the $40,000 estimate because it forces a more conservative view on breaking even. An aggressive manager might use the high-low because the lower fixed cost makes a project look easier to justify.
So the choice of method has real strategic implications.
Huge implications. Both are just approximations, but which approximation you choose to believe in can change your decisions.
So what's the framework? How do you decide? Scalpel, visual check, or blunt hammer?
It's all about precision versus resources. If you need a quick, objective number for a low-stakes decision right now, use high-low.
And if you have a little more time, want to see the whole picture?
Use the scattergraph. Get that visual check, but just acknowledge that it's subjective.
But if the decision is critical, we're talking long-term pricing, a major investment.
Then you need the precision of invoice analysis, or you need to move beyond these simple estimation tools altogether.
Which all leads to the final output, right?
Yeah.
The whole point of this is to create that predictive model.
That's the end game. You settle on your fixed and variable components, and you build the cost equation. Total cost equals fixed cost plus variable cost per unit times activity level. That one little equation drives all your CVP analysis, all your profit planning.
Okay, before we wrap up, we have to mention one critical assumption that underpins all of this.
Yes, the relevant range.
This is so important.
It provides the context for everything. This whole analysis, the 30,000 fixed, the $5 variable rate, it's only valid within the range of activity you've actually observed.
So in our auto example, that's between 6,000 and 18,000 labor hours.
Right. If the company suddenly decides to ramp up to 30,000 hours or cut back to 3,000, all bets are off.
The whole cost structure could change.
It will change. You might have to rent a new building, which is a huge step up in fixed costs. Or you might lay off a supervisor, which is a step down. The equation only works within that normal operating range. You always have to remember that.
So you now have the complete framework. You know what mixed costs are, why separating them is absolutely non-negotiable for planning, and you understand the spectrum of effort versus accuracy when you choose a method.
And we've established that while the scattergraph gives you great intuition and high-low gives you speed, for those really critical decisions, relying on a visual guess or just 2 data points is pretty limiting.
So that brings up the final question. If the scattergraph is a good guess and high-low is a rough shortcut, what's the next logical step when the stakes are really high?
The next step and the ultimate destination in this kind of analysis is moving to statistical regression. It's often called the method of least squares.
And what does that do?
Think of it as a mathematically perfect scattergraph. It uses all the data points, just like a scattergraph does, but it completely removes the analyst's subjectivity.
So no more guessing where the line goes.
None. The math objectively finds the single best fit line by minimizing the squared distance to every single data point. It gives you the most statistically rigorous cost equation possible from your data. And that is the tool you use when accuracy is the only thing that matters.